Hello once again, welcome back to the show. My name's Relevant, this is Do All the Things. And on today's episode, continuing our 12-volt infrastructure, our solar setup, I have acquired an MPPT, and now I'm gonna start roughing in the installation of the general charge station, the general command center. Stay tuned. Initially, I had some big plans because if you've been following the comedy, you know I like to build my own circuits. I've built various power supplies and battery chargers in the past. I was going to build my own MPPT from scratch. Here's one of them. Oh, a Texas Instruments BQ 2031. And, you know, I had it going, but then as it is with breadboarding, sometimes you slip with a component, something touches, and I fried it. And it's a $20 part. That hurts a little bit. I got another one, and I had that going. I actually had it hooked up to the solar panels at one point, successfully charged a small battery, and then one day I came down to the shop to continue working on the circuit, and it was dead. I have no idea why. I had the power turned off going to it, and I had it hooked up to a battery. Something about leaving it hooked up to a battery overnight killed it, which is useless because it's going to be a solar charger. It's going to stay hooked up to the battery. I must have done something wrong, but that has discouraged me. At some point, I decided I've spent enough time trying to figure out an MPPT. I'm just going to buy one. If I really wanted to, I could build one from scratch, like completely, not even with jelly bean components, just op amps and MOSFETs and logic circuits. I have it all in here. I have an idea of how to do it. I can do it, but it would take a lot of time, take a lot of effort, and it would cost more. There's also liability considerations. This is something I'm going to be installing in my house, leaving hooked up. It's not going to be like some of my other projects where I'm using them while I'm using them. You know, risks. Something glitches out, you have a battery explode. Do we want that liability? This is honestly better because for just over $100, I scored myself, you know, your classic Renogy charger. It's a Rover 20. They're from Philadelphia Street in Ontario, California. 3 different locations in one address. UPS dropped it off just like this. There was nothing taped sealing the box. This is the version with a Bluetooth module. Apparently, there's an app that I can go on my phone and see what my solar system's doing, so that's kind of cool. This didn't add much to the cost. I was looking at some other chargers. Like, I have a buddy who deals solar. I just couldn't pull the trigger on the units he was selling because the instructions, the manuals weren't clear as to how the charge algorithm works. This one was a little bit more clear. I believe I've decided at this point I'm going to be going with lithium nanophosphate, lithium iron phosphate cells instead of lead acid. They are more appropriate to what I'm trying to do. This had a slightly better explanation on how it would handle those cells. Whereas some of the other units, they imply that they handle them the same way they do a lead acid, but they're depending on the fact that lithium iron phosphate can, you know, get away with working that way to get away with working that way. So what do we got here? Plastic. Yeah. Got a big heatsink at the back. I'm wondering why we need so much heatsink for a 20 amp charger. From my experience, a PWM doesn't generate a whole heck of a lot of heat, but the diode components might. Yeah, I've gotten some 5 amp systems to generate a lot of heat on the diode, so I guess so. At least it's passively cooled. My one buddy pointed that out to me. Like, some of them have fans. You might not like that if you're running it inside your house. Don't want to do the peel yet? Oh yes, I guess that's an obligatory YouTube thing. Even though I'm one of those strangers who leaves this on sometimes. Okay, let's get some fingerprints already. We got some big, chunky boy holes. They really give you a lot of room for the wiring. Damn, you could fit like, I don't know what gauge in there. Big gauges, but I think they use the same enclosure for various outputs. As you know, my system's 135 watts times 2, 270 watts total. They're roughly 8 amp short circuit cells, so that's 16 amps. 20 amp charger should do me good. What are these? Mounting brackets of some sort? What do we got here? Where do these go? Oh, is it to do an offset mount? I might actually like that. Yeah, I think I'm gonna use that system. Here, let's get these installed right away, because if that's what these things do, that is going to be more appropriate for what I'm doing. Even gets a little bit farther away from the backboard I'll be mounting it on, so a little bit extra convection space. I guess they're stainless steel. I guess that's good though. This is clearly aluminum, so you don't want to use just any metal. Stainless steel will be more appropriate in the long run, especially a thing like this could be run under adverse conditions, you know, like out in a shed, somewhere not completely weather sealed, in a basement, somewhere where there might be just enough humidity to cause galvanic corrosion if you mix metals. Don't really have to worry about that in my circumstance. Oh, it also comes with this thing. This is going to be a temperature probe, I do believe. Yes, sir, that does look like a temperature probe. That's convenient, you know? I think I paid something like under $120 Canadian shipped to my door for this thing. Well, if this works the way it's supposed to, I can't go wrong for that price for my application. I would have definitely paid more than that to build it myself. So, diminishing gains, sir. Diminishing gains. All right, quickly just turning the main cam around. This is the shelf. The shelf that I do all my battery charging at. I got this, you know, fanciful little AC power drop right here. I plug all my chargers into that and I would have all sorts of various chargers right here. And that's where I would charge all my batteries. So what's the plan? The plan was I did a little bit of measuring and then I went out into the backyard, grabbed one of the most expensive resources I have, some scrap plywood. Is this actually 3/4? I don't think it's quite 3/4. It's reasonable though. A little bit of cutting and sanding. Here's hoping I measured correctly. Oh, ho, 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 ho. Oh boy, bud. Oh, it's actually just a touch, but that's just tolerances because I got a little bit of hang down, right? Okay, I'm gonna call it a consultant. Just need a little bit of, oh, that's a nice magnet. Just get a little bit of relief right here. Oh. Yeah, there's this little lip hanging down here. I guess my measurements didn't factor that in. Oh, a little bit in the center there. Damn, with this tight a fit, I might not even have to bolt this thing down. All right, well, let's just, I mostly measured right, but my tolerance is a bit too tight. Let's just try the old flip it around factor here. No, same deal. Okay, before we get too ahead of ourselves, I need to pilot some holes onto this thing so that I can actually screw it on there. Okay, so the general idea, what I wanted to do is I wanted to put this up against the front of the shelf because we have these holes here that are identical on both sides. Oh, it fits better on this side. The philosophy big that if I pilot some holes on this side, they're gonna match up when I flip it around. They should anyway. So how about one right here, and maybe one right here, and maybe one right here, and maybe one right here? Sure, bud, sure. Because of the DIY camera mount strategies that I featured in a much older video, I have a whole bunch of 1/4-20 hardware in stock. I'm just gonna use that. That means I need to make a hole big enough to fit 1/4-20 through here. Fat 16, sure. Will that go through this hole? Yes, it will, perfectly. All right, we should have 4 holes now, bud. Hey, punch it. Oi, just have to remove the chowder from the back end. Get rid of that back end chowder. Back end chowder. That'll do. So, wait, which is the good side here? This is the pretty side on this side here. Now, how can we get some relief on this? Doesn't look, it looks like these bolts are down all the way. I'd have to raise this shelf a bit. Like there is hardware I can loosen up to make that happen, but really what I want is less of an angle on this thing without everything falling down. I might be a little ill prepared for this project. Where's my soft consultant? This consultant is a little bit more lenient in its advice. Oh yeah, good old armory. Sometimes there's nothing a hammer can't fix. Okay, where's our hardware now? So we got some general screws of the screw persuasion, some general wing nuts, lock washers of the wing nut and lock washer persuasion, and some general fender washers of the fender washer persuasion. So my hope is that I could just pop these guys through the back here now. Oh yeah, of course, bud. Why not? Don't want to bother with lock washers. We don't expect this to move around very much, do we? Oi, my tolerances might be a bit off on this side. Uh-oh. I guess the front and the back don't exactly match. Close enough though. Just gotta get in there with a specialty tool, right? Oh yeah, probably gonna scratch the wall a little bit. That's okay, that's what they're for. There's no way a room survives a mad scientist's laboratory without a few scuffs. Yeah, in fact, I kind of see one over here already. Now that we got it mostly through, let's just try to swage it through. We'll put ourselves a wing nut on there. See if we just tighten pull it through. Oh yeah, there it goes. Okay, this is all coming together, buds. Well, that's a product of something we call stacked tolerances. And that's the reason why you shouldn't design things to such tight tolerances, so that they can stack together. Consequently, not only is this thing not going anywhere, but it's more not going anywhere than I had planned because of these tight tolerances. So, Mr. Renogy, I visualize a world where Renogy is living right about here. I guess up a bit so that we can have power coming in the bottom. Let's find some screws to go through there. Not gonna bother pre-drilling. Maybe I should. Get it relatively level by eye. Oh yeah, it's gonna be good. You know, I wanted to put something in there to offset it to get that heatsink away from the board, but these little mounting flanges they gave us, they do the job just nicely. Now, once again, I'm gonna remind you, this video is for entertainment purposes only. This is not a how to set up a solar system. This is just how I'm doing it. With 20 years of electrical knowledge, I am certain I'm doing stuff wrong, stuff that is not qualifiable in a proper solar install, like my choices of wires, for example. Very unlikely this is what they would use in the big leagues. I am going to be using 20 amp 12.3 SOOW cable, extension cord cable. And of course, 20 amp stranded, 300 volt insulation, rated to 90C. I have it on good authority that this is more than capable of doing the job that I want to do with it, even though this is probably not what we would normally use in a solar install. So if we look up, way up for the Jolly Green Giant, I have the junction box running the solar wires into the room right here. And that is where this wire is gonna go, if I can fit it through these holes. Uh-oh. We gotta fish this wire through. I don't really want it coming around the side of the shelf like, I guess I could. I need ways to secure it though. Well, I guess I can have it come down, zap strap it to here, then it's not gonna go anywhere. Okay, so we're gonna need some eye protection, because we know ceiling is gonna rain on us. We will also require some general ladder elevation, sir. Okay, so on the junkie box, need to get a punch out. Okay, let's see if this wire will go through this hole. Oh, it should. Hey, or that'll happen. Looks like I just have to loosen up on the wire choke a little bit. Okay, yeah, it will fit through the hole of this junction box. Oh, it's a slow go to get it through here, but it'll go. Just had to take the choke out. Now it's fine. All right, strip these puppers down. Need the ample wire to work with here, sir. This thing has to ground bond to the box, right? Because we have a ground wire going into here, grounded to the house. We need to get this bonded up. Now this guy here, all right, so it's pretty much ready to go now. We can pull it back, choke it down. This time of year being what it is, the sun has gone down, so there's gonna be no juice on this line. It's gonna be pretty much safe to connect. Or that. All right, let's see how this choke's gonna do with two uneven sized wires. Oh, it's gonna do just fine because it's seesaw pivots. Okay, well, let us get this ground wire in place. Okay, let us uniform these puppers down. Give it a snip, give it a snip. And now with a twist of this moray, we will have a grounded system. Let us get that wire banged down actually. Question is, will these taller wire staples fit over that? I think they will. Oh yeah. And because it's hanging out of the ceiling, we're gonna double, maybe even triple these wire hangers up. So it has to come all the way over here by where it's gonna come out of the ceiling. We'll put one up there. We'll triple it up for good measure. All right, that's tripled up there. That wire's not going anywhere. All right, so I very quickly and poorly blew a hole through this mounting plate, and I put a master cutoff switch on here. So if I need to disconnect this for whatever reason, I have a switch. Now, this isn't just any switch. You can't just use any switch, especially for DC. DC is less forgiving than AC. There's arc factor to keep in mind. I got this from the local tire store. It's 12 volts, 50 amps rated. 12 volts, we're gonna be pushing 20 volts through it, but that's fine. 12 volts is just to specify it's for a car. It's mostly that amperage rating and the fact that it's DC rated that's important. Now I just have to get this all wired up here. So black is negative. We're just gonna go ahead and get those puppers set up together here. Not a lot of room for slack the way I'm doing this. Okay, we want to color code our wires, remember? That's done with the magical, mystical, messy paint pen. Oh, we're not gonna be able to fit this rubber buddy through here. Oh, nice. Caught red-handed. Now we need to consider our switch geometry. Somewhere right about there. how to connect to that switch. We're using fork connectors. Doing the right thing. I'm using a 14 gauge fork connector on a 20 gauge wire. As long as it crimps securely, it's not really a deal breaker. I don't know, it didn't crimp securely. You don't really put crimp connectors in solid wire. Usually solid wire, you could just wrap it around the screw terminal. Don't really want to do that here. Are these crappy crimp connectors? Is that what's going on? Like the one rated for 20 gauge wire or 12 gauge wire is like freaking gaping bud. I don't see how that's gonna work any better. All right, well, let's try again. I think that'll be okay this time. Now the stranded wires where the blue buddies might not fit. No, the blue buddies fit great on the stranded wire. Well, what the frickin' fark is the purpose of the frickin' yellow connectors then? Okay, let's just get it hooked up to the switch. Doobly 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 doobly. All right, that should give us a what the frick? This fork popped out. These aren't good forks, bud. They're a bit too wide. Okay, I think I got those on there well and good now. Assuming we can flex this wire into a position that works. Oh yeah, we're gonna be good, bud. Like I offset this switch to make room for all the wiring, so it's not perfectly centered. It's just a little bit this way and a little bit this way. Okay, now with all that tomfoolery taken care of, it's just a case of wiring it in, I do believe. Now I might want to slack on this a bit, and then I'm just gonna zap strap it to the side of the shelf here. Now this shelf, it's a friggin' unit, bud. I am not worried about it going anywhere anytime soon. I am not worried about it getting knocked over. So I feel comfortable doing this, even though it's not recommended. So somewhere on here is a ground screw. Is this it down here? I think that's it down there. So we gotta slack this enough so that the ground wire can come around and hang out there. And then this is generally gonna go up into, I can't read the labels from here. Okay, well, it's the very first set. I'm pretty confident that's gonna stay there. I'm not sure that I can cut this with a normal wire. Oh, I don't know if I can cut this with this either. Oh no, that's kind of buttery. Tin snips for the win. Okay, so maybe somewhere down here, I might give it the snippy snipperson or the strippy stripperson. How about right about here? Now I figured I'd strap down on this thing one more time with a proper metal strap link like this. Right about there should do it. Yes, we can reach the ground lug. Number 8 by 3/4 screws. All right, that's not going anywhere. Once again, ground lug there. Cut that down just a little bit. Let's use more of these blue buddies since they seem to like to fit. Now this isn't the only thing I'm gonna be putting in that ground lug. When I hook up the distribution panel, I'm gonna be attaching it to that lug too. But I will pre-fit this hook to see how well it sits. Yeah, it should do. So now it's just a case of getting these guys into their holes. Positive and negative as we see it. I don't want tons of slack, so right about here. How much depth do we have here? That's what, about a 1/2 inch, 3/4 inch? All right, gonna pop that guy up through that hole, secure it down, see what happens. Hey, what's going on here? They came shut. I gotta open it, then put the wire through, then clamp it down. Okay, that feels good now. Yeah, okay, those are in there secure now. So we've got solar on this. It's dark out now. Can't really test on anything. Here's a question on my mind. If I hook a battery up to this now, is it gonna fire up and let me browse the menus? This right here is the battery out of my quad. It's a deep cycle AGM to the best of my knowledge, so it's qualified to do this kind of job. However, I think it's only about 14 amp hours, so I don't think it would appreciate a 16 amp charge. But for now, with the PV turned off, I'm gonna connect it. Wow, this is how she looky-loos right off the bat. SLO, I think that's the battery type. Oh, it thinks the battery's 90%, that's good. 12.9 volts. No amperages to the output, 0.3 amperages. No amp hours in, no amp hours out. That's all nice to have all that stuff. 22 degrees Celsius, 15. We have a 15 light bulb. No idea what that means. EO. Okay, good progress. How do we get into the menu on this thing? RTFM, bud. Load mode. Load mode 15. That's what the light bulb with the 15 meant. Programming battery type. Hover over the battery voltage screen and press down the enter button. I don't see an enter button. What does this hover over? Hover over the battery voltage screen and press the enter button. Where's the enter button? Okay, pressing it this way. Flooded, it's not a flooded. It's not a user. It's not a lithium ion. Oh, gel cell. I think that's what an AGM is. It's a gel cell. Okay, 12 volt, okay. Back to the main menu, it says SLD, sealed lead acid. Well, that should qualify too. To enter the programming interface, simply hold down the right arrow button. I should stop dicking around with this and wasting all our times. What I should be looking for is if I can program battery current. It doesn't look like it. And I just ran out of English manual. Oh, okay. Light bulb 15 means it's set to a manual mode. You can set a timer that turns your load on and off. That is the output of this thing that goes to your light bulbs, inverters, whatever you would have. So you can set it up to run during the night when you need light, or run during the day when you have solar power. Apparently, I could just turn it on and off with this button. Well, that's good to know. Okay, so I'm not gonna bother leaving this guy hooked up. Carefully leave that connected and boop. All right, the fact of the matter is you can have as much PV in the world as possibly human capable of accumulating, but it ain't gonna make a lick of nothing if you don't have something that it plugs into. And that's what we got going on here. I'm going to be building some form of distribution panel for this thing. So I got this box here, this label ripped as I was opening the package, an UCO 884. It is a, proper metal enclosure, 8 by 8 by 4 inches deep, and it has a hinge on it so we can access the internals. Oh, look at how silly that is. I guess you could put a lock on this thing if you really wanted to. We're gonna be taking this top off for now because we gotta drill a bunch of holes in it, bud. See here, this is a distribution thing. I acquired this at a, what do you call those things again? Yard sales. Yeah, comes with fuses. What are these fuses? 15 amp fuses. May or may not be able to use those, but they're common fuses. I have others in stock, and we have switches to turn on and off the various routing, if you will. I think this would be perfect for this application. We just have a power bus coming in, and then various power buses going out. As long as we don't exceed our amperages. Oh, this is only 18 gauge cable, bud. How do they figure? They have 4 15 amp circuits, they're pumping it just through 18 gauge cable? Oh, what rocket scientist designed this thing? We might have to redesign this thing. Well, actually, we don't, because for the applications I'm gonna be using it for, it should be fine. 18 gauge cable, chassis wiring like this, it's good for at least 8 amps, I would think. I'm not sure that there's anything really that's gonna be pulling 8 amps. I think I might replace this first thing here. Yeah, we will solder directly on. Better, more skookum wires here. And then everything else can break out to 18 gauge for all I care. Now, in order to connect this to the various chargers I have planned, we need several implements. Here, we're gonna have some banana clips for banana clippy-like things to just tie on power. Then we're gonna have at least 3 of these guys to plug in various chargers, because a lot of chargers run off 12 volts. They have a barrel jack on them like that. We're just gonna get jumper cables, barrel jack jumper cables, jumper from here to the charger. Oh, and then finally, we got one of these guys right here. Oh yeah, buddy. So I'm talking about a proper 12 volt power port with a very springy door that I don't need because it's designed to be operated externally. They made it weatherproof, but we don't need weatherproof. Yeah, let's start off by disabling the weatherproofing. Pop on that spring, pop on this spring and pull. Oh, the entire thing comes apart. Yeah, we'll just use it like that. This is gonna let us plug in like USB chargers and stuff. They got some crazy lock ring here. Now, how do I want to orient this? You know, you kind of assume you're just gonna do one of these. Oh yeah, open it up. Oh yeah. Okay, oh, there it is. Oh, we got some ground screws here. How are we gonna lay this out though? Kind of want these things down near the bottom. These guys I plan to have pop it out the side. Okay, there's lots of room for all this crap. Just have to get to caravan in there somehow. Oh, you know what? We gotta pull this all apart so we can template it on there. If it will let us. These wires wanna be on there tight. You know what? I don't have to disconnect the rest of these wires. If I could just push these switches through. Oh yeah, okay, we'll be good. How much power you figure these switches use? Hey! I think that was the switch contact I just shorted out there, buddy. Well, that's always a fun time. The frickers aren't clearly labeled, are they? No, they're not. Doesn't appear I damaged the switch. Burn the wire off. Oh boy. I guess it was this other terminal. Okay, well, let's test on it to be sure, right? Oh, look at that nice cute glow. 40 milliamps. These will consume 40 milliamps while I'm operating the circuit. Do I want to pay for that much overhead while I'm charging? Heck, why not? It's free power. They appear to be filament bulbs. They'll probably blow out eventually anyway. These are 15 amp, 120 volt AC rated switches with a 12 volt bulb in it. Okay, That also suggests to me that these aren't DC rated switches. Is this, well, it must be. They have 12 volt bulbs. I don't know. Let's just roll with it. Okay, we got our little template out here. And I guess we're gonna put it right about here. Actually, it looks like we can put it down a bit more. Maybe here. That'll give us room to add crap up here later. All right, that's our layout. Let's get the door off. Looks like we can just pull this thing out or press it out. Now this guy here comes with a lot of 16 gauge cable, which I do believe we can just separate with this. What amperage is this fuse? Also a 15 amp. Now hold on here before we go too crazy. We have these punch outs on the side. What are the chances this is gonna fit in that punch out? And then maybe we'll just side entry exit. Yeah, you know what? That seems like a really clean and convenient way to do this. Oh, not quite, bud, not quite. But we have 2 layers. Without ruining too much of my paint, bud. Let's give her. Oh boy, the other side's a bit on there, bud. Now how does it look? Oh boy, that's pretty sweet actually. So what's the purpose of this sharp metal ring? It looks like it, like these bits would slip into those channels. Okay, bud, RTFM. There's no R to TFM. Okay, so this is gonna start clickety-clacketing. Oh, yeah, it's gonna bite into the metal. And it's gonna give an anti-rotational effect. Huh, you know what, that's on there pretty good now, actually. Okay, that's actually more convenient because, you know, the kind of stuff that sticks out of here, it'll be better from the side. All right, on this guy, we pretty much just have to worry about the 3 outputs there. And then all this crap. This is not good for the ears. I need something to put under this. Square hole subtypes entail several round holes. All right, let's set up Pressy Boy. Now, admittedly, I've never had much luck doing the drill many small holes thing, but we're gonna give it the old college try, right? We'll get everything warmed up, drilling out the little holes. Probably gonna mount this using 632 hardware, so let's get that done. Oh, I should have piloted this on the other side. The good news is now we can see the back of this. We can start going at it from this side. We need to step bit these guys up to size now. That means utilizing our coiny butts. Coiny butts, yeah, coiny butts, sure. New for 2021, coiny butts. All right, these guys get to be 1/2 inch holes. Yeah, the healthy chatter of a cone bit. Oi! Ah, come on. Well, I do believe that's the hardest I've ever worked a coney bit before. This thing looks like hell. And, you know, we got a little bit more to go before a switch is going to fit it there, but now we have to elongate those things. How do we go about doing that? Oh, probably going to have to bust out the rotary tool, right? Like we don't already have chips flailed around everywhere. We're going to have to flail around more chips. Well, let's give it a try, see how it works anyway. Oh, that was certainly an interesting adventure. Look at them sexy apprentice sparks, bud. You gotta love it. You gotta love it. That's just awesome sauce work right there. My ears. They seem to be experiencing a bit of fatigue now. Well, we can clean this up. Well, I got no choice. Can't leave it like that, right? All right, still looks like hell, but at least it looks like hell with smooth edges. And I barely even cut myself. So, how well do you think this is gonna fit over? Let's check the overlay. Oh. Some of these still need just a little bit of widening, but otherwise, damn, pretty close. Pretty close. Well, let's try popping a switch through the worst hole and see how that looks. Actually, it's gonna work, I think, yeah? Oh. Trying to fit everything in there, see what happens. We're plagued with alignment issues, sir. Well, of course we are. Did we think that was just gonna come together easy? No, of course not. And of course it's not gonna come together easy. Now, mind you, the alignment issues seem to be mostly associated with the fuse holders, which is a slightly easier solution. Just embiggen them another step, right? Okay, this time for sure, right? Plop, 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 smack, smush, and one more, bud. Smush, and we're good. We have the distribution panel now officially installed onto the distribution panel. Bud needs to be better with his words. But I think that's it for today. It is late, and this is probably going to edit into one whole episode, so stay tuned. Stay tuned, because in the next episode, I'm going to assemble this, finally, after cleaning up this massive mess, and we're gonna get it installed onto the board. Now I have to start shopping around for a battery. Yeah. All right. Fab is fun, but the mess after is not. Oh boy. Oh boy. Oh, and I didn't even drill the side holes for the banana plugs. Next time.